This is the control head off of a Jobo or Jobo CPP2 print processor. I paid way too much money for this thing. But anyways, this sits on top of a giant plastic basin, and it heats the water so it keeps your chemistry and your developing tanks for when you're doing film or in large print processing at the correct temperature. It also has a motor in it, so it actually rotates the tank at the same time. I actually haven't had this at the house for quite a while. It was more of a surprise. I had to get this back out of the makerspace. They were moving and they had to find homes for everything that had been left there for a while. So I had it there and I had people using this here because I wasn't going to be using this thing on a regular basis. Anyways, I got it back, did the checkout, turns on the thermometer and the thermostat. That is correct. That all works. I mean, it sounds like it's dry, but that works as well. And then the motor. First off, I don't hear a detent on it, that's new. Okay, we'll get back to that. I bet you that's my problem. I turn that, and that should be, well, even there at like full speed or whatever, and the motor doesn't do anything. So it should turn. There's a switch here. Doesn't seem like it's a bad relay. I don't even hear the relay clicking in it right now. This is a fairly common problem with these. So CPP2s being art objects, I find that, and I'm going to be biased here, but I have my gripes because it seems to be fairly consistent when I had to deal with these people. If it's equipment that's not owned by them, they'll run the equipment into the ground, and if it breaks, they'll just walk away and hope you catch it at a later date. Thanks, whoever did this. Anyways, trying to get support for this thing. Well, you can look around on forums, but it's the usual thing of like, I don't know how to fix this, or, oh, you can just buy another one, or like, you can contact this guy and he sells parts, but the post was like 15 years ago, or it's just like, oh, I converted my entire system over to this 4-layer, like, ESP microcontroller, like, nightmare. Why the hell did you reinvent the wheel? These things are not that complicated. Anyways, like, these are from like the late 80s into the early to mid 1990s. They still actually sell these. These are very expensive. Last I checked, I think they're like 1,200 euros. Plus there's other add-ons you can get for it. So I do have a reason to fix this. I don't have any space to be processing in large prints in my bathroom, so I was using the Jobo, whatever we're going to call it, to process them in a tank in a fairly small, compact manner. So I have reasons to fix this. So let me dig inside of this and immediately see what's going on. So the knobs just pull off like that. Don't lose the bit of felt underneath there. Those can go over there. This, that I can tell, is supposed to come off. There's actually an Allen key up there, and I can take that off, but I can't yank that off, and I got nowhere to pry against it. So I'm hoping I don't have to deal with this. It's also taped in here right now, so cool. But on the underside here, I just have these screws in the corners there, 3, so we 4, 5, and 6, and it's interesting. I've tried to take these screws off. This front panel doesn't come off. It's interesting. Okay, you do have to peel this tape back, at least, to get in here. And then this pulls off. This doesn't come off. Someone has been in here. This does not feel... It feels like someone sprayed some sort of waterproofing, or something's going on inside of here. Also, this... It smells like black licorice. I don't know why I can explain it like that, but it smells like black licorice, and it's just a hard material. Anyways, so inside of this here, we have our temperature control board, which is living up here, and here's our knobs that control that. Here are the, so it's power, pump control, this one, okay, and this one here is our motor control. And I distinctly remember there's a detent on this here, and oh, it's right there. Something doesn't feel right about that switch. This is going to come back to get me. Just watch. Alright, well, we'll go through this anyways. So, here's the motor. Now, from searching around, I find that there's a lot of people who complain about these motors. This unit's gone through several revisions over the years, and I guess the motors are either not water resistant enough, or the motors are just underpowered, or they just wear out, their brushes wear out. So it could just actually be that someone was using this and they've just worn the motor plumb out. So we have to test that. It's these two wires here. It's black and green. I've also been told before that there's a temperature switch on here. And if that temperature switch is tripped, it doesn't work. Well, I can look right here and I can see there's our temperature switch. And at least for these two wires here, that has nothing to do with that. If anything, it's a brown wire, and the brown wire goes to our heating element. That makes more sense. If the reservoir is dry, I don't see why that would turn off the motor, much less turn off the pump that's living over here. It's got a fan on it. But turning off the heater when it's dry, that makes sense. Okay, I'll take the motor out. Okay, so here's our motor, and if I can do this carefully, if you look in here, you might see something spinning. Or not. No, it's stiff. It could be that the lubrication in here is dried out. I'll take a look at that. The easiest way to test this is to plug it into a bench supply, but I don't want to go into the other room right now. But because this is just presumably just a brushed motor, if I am to attach this to a multimeter, set it to volts, like DC volts, and just turn this, I should see a voltage, because this will work kind of like a primitive generator. If that's the case, then I know that the windings and the brushes and everything inside of here is okay. Okay, multimeter set to DC volts. I'm going to try and turn this with one hand and see what it does. Oh yeah. I mean, I could have done a continuity check. Actually, let's do that. It doesn't seem like a dead short. That's good. So it's not a shorted winding. Okay, let's plug this into the bench and see what happens. And yes, I did take the cover off the gear housing. The grease in here, it's old, but it's not thick. It's still actually quite nice. I'm not going to put my hand in it. You're just going to have to trust me here. What I like to do is put, if it's a compatible oil, I usually put a little bit of sewing machine oil in there. I can't so much say it wets it, but the idea is that you're just trying to add a bit of oil back into the grease compound, and usually it loosens it up a bit. I don't need to soak this in oil. Hell, this is probably fine, and I'm probably making it worse, but sure, I'll add a little bit of extra lubrication in here, but grease doesn't appear to be our problem either in this. Motor's on the bench, wired up to here. The spec on the motor says 24 volts. We'll give that DC and see what it does. Oh yeah. Sounds great. Sounds good. My amperage seems very consistent, so it's not like it has dry spots. So let me just flip the wires around. Okay, yeah, and it works fine the other direction as well. Okay, I have spent a considerable amount of time here just testing the motor. It's not brushes, it's not winding, it's not grease, and we know if we power it, it works both directions. It is not the motor that is a fault here. Why am I saying this so much? Because there's a lot of threads and a lot of information I found online that says, like, if you have a problem with the your drums not rotating, it's going to be the motor. Well, it's not the motor. So we're going to have to follow backwards and figure out where, if any, power is coming from on this. Okay, motor is wired back in, multimeter is plugged in, and I have, come on glare, there, no DC power at all from the potentiometer. So that is no good at all. Do I have AC power? I want AC, there we go. There's something there, but let's consider that no, there's nothing there. So there's no power going to the motor. Okay, let's follow back. Let's check those fuses. Okay. First fuse is good. Can I get this one? Oh, what's this? Oh. Okay, I can hear it beeping. Come on. This is really tight and annoying. There we go. Now that one's good too. Okay, so those fuses are good. That there is going to be our line fuse. And I bet you... yeah, it's fine too. So we know for a fact, AC power's coming in. I know for a fact the power switch here, I'm assuming that's the power switch, is working because the fuse is good, and I turn that on and I get a display. So that means that I'm getting DC power to at least temperature control. Motor works here, but that's an AC motor, so that's probably controlled from up here as well. And the heater works as well, which is AC power as well, I'm pretty sure of it, which means that the thermostat's good and it's getting power as well. And I'm assuming in that case there that the temperature control is also working because it's supplying heat, unless it goes full on when it fails. I have no idea. Okay, oh god. I'll take out these boards here and try and get down to this one here and pull this one out and figure out what's going on there. This is such a stupid design. The bottom of this is painted with some sort of material as well. I'm assuming for chemical resistance. I don't know why. It's plastic. But what I'm noticing here is that there's various places where I can see there's corrosion. Like on the bottom of the thermostat. And where else did I see it here? Oh, on the bottom of like this board here I noticed a bit of corrosion. So what can happen, I guess, is at times water can get into here. Developing compounds can get into here. There's no drain. If water or anything gets into here, there's no drain. It can't escape. So I can totally see that if like some water issue occurs, this becomes a water hazard. Like there's nowhere for it to go other than to just fry everything in here. I almost want to drill a hole in this just to make one weep hole. Doesn't need to be big, just enough for if water pools in here, it can find somewhere to drain out. Anyways, so I've got this board out now. We have this beefy transistor here. I'm assuming another one over here. What are you? TIC246M? Okay, I'd have to look that one up. But here's our transformer. So let's start on this here. And it looks to be converting your line voltage, 115, to 20 volts and 10 volts. I'm not sure what's like 1 to 7, 8 to 11, 11 to 14, because there's only 5 points underneath here. As for these fuses, since both of these were good, these look like they are the outputs of that transformer, so it's protected just before the transformer. That's nice. Okay, let me try and mark these out and figure out what each one does. Okay, so I have the 120 volt going in. There's line and neutral going in, and I have the switch turned on up there, and we're powered up. So these are actually live right now. So I should see line voltage on these two solder points. And I got 121 volts right now going in. And so what I've determined is that this is a center tap transformer. So here's like a winding on the secondary side, and not so much in the middle, like a little bit more on one side of the winding than the other do we have that center point. So that's going to be our common. And I will try and get this in here, and what I saw was that this side, if I can get a good contact on this, it's actually kind of dangerous. Come on, I know, there we go. It's like 23 volts AC right there. And if I go around to the other side, common, and our 10, come on. There we go. We have 12 volts AC. Now that's fine. Like, because the line voltage on the primary side is going to be fluctuating between like 110, 120, you're always going to see kind of a similar voltage change on the other side here. So if this is getting rectified to DC, that like change of several volts isn't going to matter. So I've labeled that there. So we've now determined that one of the other possible failure points on these, the transformer, is not the point of failure, because right now it's, well, the primary is good, the secondary is providing at the very least one voltage rail that's powering the rest of the unit up. So that's fine. Now I need to figure out at which point this gets turned on to a DC voltage and test there. Okay, so these little guys right here and right here, those are bridge rectifier diodes. So that's actually a group of, that just fell over, that is a group of 4 LEDs which convert alternating current to direct current. This here is the primary filter capacitor for the rectified DC. And this little guy down here is the primary filter for the rectified 12 volt DC, 24, 12. And this here is an LM7805 5 volt voltage regulator. And it has a cap hiding somewhere around here as well. So we should have 24 volts DC, 12 volts DC, 5 volts DC. So that should be our 24 volts and ground. And we have, come on, we have 31 volts. Okay, that's high, but we'll keep that in mind that there is a voltage present. There is our 12 volts in ground, and we're getting like 14 volts, 15 volts. Why are these voltages so high? Weird. I usually expect a drop when it goes through a bridge rectifier, not a rise like that. There must be a pump circuit or a charge circuit in here somewhere. But why? Anyways, 5 volts. 5 volts is actually passing through a dedicated regulator. It's not just going through a transformer winding and a diode. And that's 4.9 volts, so we're basically on there. Okay, so we have our voltages. What operates the motor? Okay, so here's our two motor terminals, motor negative and motor plus. Our relay is living right here, and then I can see, whoops, anyways, that you can see, all the relay does is just switch M plus and M negative. Because it's DC, the motor reverses direction. So that's how this is controlled. Motor negative is just ground. That's fine. And if I switch that over there, motor plus should be 24, but it's not. But that makes sense right now, because when the unit's not needed, there should be no voltage going directly to it. So that gets turned on by somewhere. And I know there's a giant beefy resistor. It's passing through that, and it ends up there. Okay, no, let me double check this. Okay, no, I had that reversed. So that actually goes out to the resistor and it comes back out over here. Over here. There we go. What the heck are you doing? There. So it's right there. It comes over to here. There's a thinner wire that goes up over to here, but it also terminates at this transistor right here. So the other side of that is 24 volts. So there's our link there, and that's where our break is. So this transistor controls the on, off, and speed of the 24 volt drum motor. So we know here with a transistor, it's basically a switch that can also be made variable in some cases. What is this actually? This is a TIP 140. It's a beast too, so with a heat sink, so that's handy. But so we know the heat sink, and the heat sink's tied together there, so that's that. So what we're looking for, what drives that? Okay, so that exits out, and it goes back over to the digital board, which is flopped over here. So I'm going to take a look at that. Okay, so this goes up, goes into here, 1, 2, 3. The harness reverses, so it's actually, where did I see it here? 1, oh. Unplug that. Okay, it's unplugged. Is that... I was in continuity mode. What was that? Right, where was I before we got paranormal here? Okay, right. So, 1, 2, 3. And it goes down here. And you gotta trust me on this one, there's a resistor right here. And that resistor that I've checked is like 100 ohms. But it goes through to the other side. Okay, 150 ohms. Sure. But that runs down. And it goes... Where the hell does that go? There. There, down, around, and it goes into a chip right there. So this whole section here that I can tell is dedicated simply to controlling the motor. So we either have a bad transistor or something over here is not driving it. We're also now getting very close to that potentiometer, which I've been suspect of this whole time. But I've been completely ignorant on testing it until now, just until we covered everything else for the sake of making a troubleshooting video. So let's take a look at that now. This is a 10K potentiometer. So right now I have it turned all the way one way, and I'm on one side of what's going to be the ring here. So if I go to the center contact, what am I? 10K. And if I swish it all the way to the other end, what am I at? 0. Now, is that broken at some point? Actually, it shouldn't be broken because I have a distinct, like, it's working and it's not, and I traveled the knob the whole way. Okay, what happens if I can I twist this with a finger? There we go. There's our 0. 2, 3, 4, 6, 7, 8. Okay, no, so that's fine that direction. Let me just switch it around. Okay, have it spun around here. There's our 10K. I'll just turn it down. 8, 7, 6, 5, 4, 3. Well, I'm just kind of 1, 2. Okay, no, that's fine. Okay, no. So for a 10K potentiometer, that's nice and smooth. That's nice and clean. But where's my detent? I have a feeling that this is a lot more like an old radio volume knob, where not only is it the volume control, it's also the on-off switch. So it's actually stacked. And you can see under here that there's something else living underneath of this. Let me get to the underside. And here on the other side, so there's our potentiometer, there's our center, there's one side, there's the other side. And then there's these two contacts here. This is just going up through here to there, and that's underneath that whole knob. I have no continuity. And I know right now I have the knob centered, so that should be on. And I have no continuity. So that looks to be the smoking gun. So if it's open right now, we get no motor operation. So if I bridge that with power applied, I bet the motor will just start working. This is astoundingly janktacular right now. Like, there's live voltages everywhere. Is it on? Yes, it is on. It should be still centered. I heard a relay click. That's interesting. Okay, so I got to go in there with the screwdriver and bridge those two contacts. And there it goes. And it reverses. Now it's unhappy right now because this is not allowed to spin, but there we go. So it's a bad switch. Okay, let's take that out and figure out what to replace it with. So here it is. And it's made by a company. Where is it? There. P-R-E-H. Pre? It's a German company. I'm almost positive of it. So there's our potentiometer on top. There's our switch underneath. I wonder, it doesn't look like it's got melted plastic here. I wonder if I can slide this off once I get this glue off. Because, yeah, no, like, there's no click. Nothing. So, even if I break this switch down here, as long as I don't break the one on top, we should be alright. I don't know if this is going to focus. But there's our problem. Gonna focus on me? You are not gonna focus on me. Anyways, the thing I have in my hand here, that is the, like there's a spring on one, whoo, and it is gone. Goodbye, folks. That switch is junk at this point. Anyways, I was gonna say, so you have this little tiny swing arm here, and that just simply swings back and forth. And there's a spring in there, and it also sits on a little tiny socket. And on this side here, you have what is essentially your contact, and when that spring buckles, it either opens or closes that switch. Well, before that launched off like a rocket, the actual like mount that this mated with and slid along has broken, so it had popped straight off. So there was nothing you could do about that. So that portion of the switch is no good. I managed to find the spring, not that it really matters, because as you saw, like that rocketed off that way, and the plastic piece just kind of fell down somewhere, and gravity did the rest. But like anything that hits my floor, it's gone. It's disappeared. Which doesn't matter too much, because that was broken at this point. Okay, so we're safe to assume now that we have a dead switch in here. So I can try and find another one of these. And according to the internet, this is a discontinued part now. I could also very easily hunt down a 10K pot with a, God, it's not even going to be in inches, 20 millimeter stem on it that's D-shaped. And I mean, that'll work as well. I'm just going to do a quick and dirty hack to get this thing back together. What a piece of crap. I don't even know what the hell I came from. I don't even know what the hell this came from. We have like one lead here, which goes into a 4-pin, which I'm not using half the pins. Then it goes out here, splices into lamp cord, and I've just drilled a hole and installed a toggle switch. There we go. That is our new motor on-off switch. There's our variable motor control. Let's just put this thing back together now. Alright, it's back together. The CPP2 has the lift CPA2 sitting on top of it. CPP2, whatever. And there you go. And this is it all reassembled. And again, like I've been mocking it so far, this thing says it's made in Germany. What a piece of crap. This is made in West Germany? Come on. It's got like the price tag of a Mercedes and the build quality of a Yugo. It's just mainly plastic. I'm more annoyed for the fact that I leave this out for other people to use, and, well, those go missing. 3 of my chemistry bottles are missing. And sure, I got my medium-sized print developing tank. All my film developing tanks disappeared. But I digress. So, this knob here is now just simply, well, exactly as it shows. I think when it's in the 0 position, does it run? Sure does. And if I just turn up the speed, there we go. And that's all it does. If you're seeing this little thing in the corner here, that's actually what's controlling the direction there. It's just to help with the agitation of the film so it's not constantly spinning over and over and over the same way. Other than that, no. Okay, we're done. I hope this repair video was informative. There's really not much else out there. In one case, it was as infuriating as we had 2 units. Neither of them worked, so we fixed them. End of blog. Remember to like and subscribe. Well, now we know if for some reason the detent on this here doesn't feel right and the motor doesn't work, odds are that the actual on-off switch that's part of this potentiometer is bad. In my case, I just went and put another switch in here, which lets me turn it off. And then I can tell, okay, it doesn't complain if you have it all the way into the full speed position, but there's my new switch. Grounding, whatever. Moisture incursion, whatever. I don't care. It's so much plastic, so many gripes. But if the motor doesn't work, this is weird, this is the first thing to check. And we've gone over the rest of the circuits, so now if you go into this and you wonder about what the other parts of that circuit do, especially for motor control, now you know. I hope this was informative. And until next time, have a good one.